Okay, so today we will go over the rest of the sample exam and we will start with the problem 17. So the question is asking find the class width for the frequency table below. So remember that class width can be calculated by subtracting the smallest value from the biggest value and divide it by the number of classes that we have, right? So in this case, we don't exactly know what is the biggest value, but we know that we have here 43 and 34. So let's try that. 43 minus 34 divided by how many classes do we have here? We have 2, 4, 5, right? So we have 5 classes right here. So what would be in this case the answer? It's gonna be 9 divided by 5, which is 1.8, right? So in this case, we can just round up to 2, or another way, and this would be the class width in this case. Another way you can analyze the graph, I mean, the frequency table is you need to remember that class width is the distance between the between the lower limits or lower boundaries of two consecutive classes. So what you can do in this case, you just find the distance or the difference or difference in this case maybe, right? Difference between the lower limits or lower bounds of two classes. So 36 minus 34, or we can choose the difference between these two, which is 38 minus 36, or between these two, 40 minus 38, and 42 minus 40. In all of these 4 cases, the difference would be 2, right? So that's your class width. So you can choose any 2, right? And calculate their difference, right? So you don't have to do that for all of them, but when you're constructing your own frequency table, keep in mind that the difference should always be the same. It should be consistent throughout all of the lower limits, and the same thing goes for the upper limits, okay? So in this case, the correct answer would be A. The class width is 2. Now for the second problem, we have construct the frequency distribution. Okay, let me go down here. So the June precipitation amount in inches for 40 cities are listed below. Construct a frequency distribution and relative frequency distribution and also cumulative frequency distribution using 8 classes, right? Starting from 0.5. Okay. So now let's first figure out what we have as our minimum value and maximum value. So since we said that we need to start from 0.5, that's going to be for the lower limit of the first class for our frequency distribution table, right? So we have classes. We have here frequency. We can have here relative frequency and cumulative. So that's all that we are asked to find, right? Now, we know that we need to start from 0.5, but what next, right? So what we know is that the minimum is 0.5, the maximum is, let's see what we have here. I think it's 4.0 in this case. I don't see any other value that is greater than that. So we want to find the class width, which is maximum minus minimum divided by the number of classes that we want, right? So in our case, we have 4.0 minus 0.5 divided by the number of classes that we said we need to construct is 8, right? So we divide that by 8, and the answer would be 0.4375, right? So I think it's a good idea to round it up to 0.5. I think that will fit all the data. Let's check if everything is fine, right? So we have 0.5 as our class width, and we start with 0.5 as well. So the next lower limit for the second class would be 0.5 plus the width, right? It will be 1.0. The next lower limit would be 1.0 plus 0.5, right? So that's going to be 1.5. The next would be 1.5 plus 0.5, which is just 2, right? And then we keep on adding our 0.5 every time. So this is the first class, second class, third class, fourth class, fifth class, sixth, seven, and eighth class. So we would have 2.5, 3.0, 3.5, 4.0. So these are all the lower limits for all of the classes that we have, right? Okay. Now, how do we calculate the upper limits? So upper limits would be one decimal or one digit, one decimal digit smaller than the previous one. So we would have here 0.9, right? Here, next one, it's going to be, so we have 1.5, so one digit less. So essentially we have, oops, we have 1.5 minus 0.1, so that's going to be 1.4. Next one, we have 2.0 minus 0.1, that's going to be 1.9. Then we have 2.5 minus 0.1, it's going to be 2.4. And for the rest of them, that's going to be 2.9, 3.4, 3.9, and 4.4. All right. So these are the intervals. Now what you need to check is that your first class should contain the smallest value. So we said the minimum value is 0.5, and it goes to the first interval or the first class. And your maximum is 4.0, so it goes into the last class, so everything is fine, right? So now we can start counting the frequencies, right? So we have, essentially, we have 4 numbers that go to the first group, 2 numbers for the second group, 7, 9, 2, 10, 2, and 4, right? So these are going to be the frequencies. So we'll just simply, we go over all the data set, right? And we start kind of putting the numbers into the into their where's that over here? Into their classes, right? Now for the relative frequency, what do we do? First thing that we need to do for the relative frequency, we need to calculate what is the total number of frequencies we have, right? So total we have here, we either add them together, or if we are given already that, wait, not, for 40 cities, Yeah, so we have 40 answers here, right? So the total should add up to 40. Okay, so now to calculate the relative frequency, what we need to do is we need to divide each frequency by the total, right? So we have 4 divided by 40, which is 0.1. Then 2 divided by 40, which is 0.05. And 7 divided by 40, which is 0.175. 9 divided by 40, that's gonna be 0.225. Then 2 divided by 40, that is again 0.05. And 10 divided by 40, that's gonna be 0.25. Then the last two, we have 2 divided by 40, which is again 0.05, and 4 divided by 40, which is just 0.1. So now when we add all of these values together, just to check our calculation, they should add up to 1, okay? Now this is relative frequency. Now cumulative frequency, remember that we start with the smallest value, right? And we start adding the values to the next as we move along, as we move down to the with the classes, right? So the first class, the frequency was 4, so we keep it as 4. Next one, we have 2, right? So for cumulative frequency, we're essentially asking what is the frequency of all of the data from the beginning up until this 1.4, right? So we are counting all of these two frequencies for both classes. So we have 4 plus 2, which is 6, right? Now the next one, where again, it's going to be 7 plus everything before that, right? So it's going to be 6 plus 7. We have 13. So for the next one, it's going to be the previous ones, right? All the previous ones together with the new one, right? So that's going to be 13 plus 9, which is 22. Next one, again, we add 2 to the previous one. So 22 plus 2, that's going to be 24. And for the next one, we have 24 plus 10 now. So we have 34. Then for the next one, we have frequency of 2. So we count all of the previous ones together with this 2. So the answer essentially is, so we have 34 plus 2, which is 36. So we have the cumulative frequency for all the classes up until the 7th class, right? It's gonna be 36. So all of these values up until this point. And for the last one, we have 4. So we have 36 plus 4, which is 40. Now, if you did all the calculations correct, the last value for the cumulative frequency is supposed to be the total number of values that we have, or the total number of, what are we working with? Cities, 40 cities, right? So that's going to be here 40. This is how you know that you did it correct, okay? Next question is construct a frequency distribution for the data using 5 classes. Okay, so read the question carefully. Construct a histogram, and so we need to construct the frequency distribution histogram, and we want to describe the shape, right? Describe the shape of the distribution. So we're given the data, ages of dishwashers in years in 20 randomly selected households. So we have all these values here, and we are asked to create 5 classes, right? Again, what is for class width? We need to find what is the max, what is the min, and we need to divide by the number of classes that we need. So maximum in this case is 15. Minimum is 1. So we have 15 minus 1 divided by 5 classes. That's what we are asked to do, right? Divide by 5. So we have 2.8. So I think that would make sense. So since we're working with the whole numbers, that would make sense if we round it to 3, right? So now we start from 1, okay? And then that's our first class, second class, third class, fourth class, and fifth class, right? So we start with 1 because that's our minimum value, right? And then we add 3 to that, right? So the next one would be 1 plus 3, that's going to be 4. So that's the lower limit for the second class. Then again, 4 plus 3, that's going to be 7. So that's the lower limit for the third class. 7 plus 3 is 10. So that's a lower limit for the fourth class. And 10 plus 3 is 13, so that is the limit for the fifth class. Now we need to calculate the upper limits, right? So in this case, since we're working with the whole numbers, then we can safely say that the upper limit for the previous class would be 1 unit less than the next than the lower limit of the next class. So in this case, lower limit for the second class was 4, so the upper limit for the previous class is going to be 3, right? You can also write 3.9. It's not a mistake, or 3.5, but since we're working with the whole numbers, you can simply say that it's just 3, right? So it's not going to be a mistake. So it's 3, or you can write it as 3.9 also works, right? So the next one will be either, so 1 less than 7, it's 6, or you can also say 6.9. Next one will be 10 minus 1, that's just 9, or 9.9 if you want, right? And the next one will be 13 minus 1, so that's going to be 12, right? And then to calculate this one, we can find the lower limit of the sixth class that we're not going to be using, but just as a placeholder. So 3 plus 3, that's going to be 16. So we would have that 16 could have been a lower limit for the sixth class if we were asked to calculate, to find the to construct the six classes. So in this case, it's easier to calculate what is the lower limit for the sorry, the upper limit for the fifth class. So that's going to be 1 less than 16, which is 15 in this case, or 15.9. I will be just using the whole numbers, but again, look at the raw data or the values that you have. If you have any decimal places here, or some values in decimals, then don't forget to put the decimals here as well, okay? So now we can erase the 16 because we don't need that. We need only 5 classes, and we need to check if the minimum goes to the first class and the maximum goes to the last class. So minimum is 1, and it goes to the first class. Maximum is 15, so we can see that it goes to the last class. So we're good. We can continue on with this interval, right? So we have classes here, and then let me move that down. And then the second column would be frequency, right? And now we just start counting the values in the raw data, right? So we have 12. 12 goes here, so we have 1. Then we have 6. 6 goes here. 4 goes again here. 9 goes to the third class. 11 goes to the fourth class. 1 goes to first class. 7 goes to the third class. 8, 9, 8 go to the third class again. So 8, 9, 8. Then we have again 9. We have 13. It's the last class. 5 goes to the second class, 15 goes to the last class, 7 goes to the third class, 6 goes to the second class, 8 twice goes to the third class again, 2 goes to the first class, and 1 goes to the first class. So we kind of added one more um column. You don't have to do that. You can just count in your head and just write it somewhere. We added a tally here. You don't have to do that if you want. That's easy just to keep track of everything. So now we just write the frequencies we have for the first class. We have 3, and then we have 4, then 7, 3, 6, wait, not 7 here. I have here more. I have here 3, 6, 9, 2, and 2. How many do we have? Yeah, all 20. Nice. Okay, so now from here, we will construct the histogram. Okay, so our x-axis will be the class's lower limits in this case, and the y-axis or the vertical line would be the frequencies. So for the frequencies, I think it's not a bad idea to go by 2. So we have 2, 4, 6, 8, and 10, right? And the classes, we will start with 1, 4, 7, 10, and 13. Okay? And we just start graphing our bars, right? Remember, in histogram, they all touch each other. So what we have here is the first class from 1 to 4. Essentially, we have the frequency of 3. So it's somewhere here, right? So that's going to be here. Second class is frequency 4. So that's going to be here. Now the third class is 9. So it's all the way up here. Right? And the last two classes, okay, so let me also mark another one for 16. So that's where we will finish, right? So we have last two classes, these are 2. So we have 2 for this and 2 for that one. So we have 5 classes, right? Now, let's look at the shape. It is approximately normal, right? So we have some values on the left side, some values on the right side, but the majority or the peak happens somewhere in the middle, right? So we have something like this. It might be a bit skewed, or maybe here it would be ideally bell shape if, for example, the fourth class had a bit higher frequency, but that also works fine. So we are approximately normal. We are not skewed anywhere. We are not uniformal. So the answer for this question would be bell shape. Okay, next one. Create or construct a stem and leaf plot for the data. So the number of home runs that Mark McGwire hit in the first 13 years of his Major League Baseball career is listed below. Construct the stem and leaf plot for the data. Okay, so now first thing you need to do is just analyze what numbers we have. We have some ones, we have the tenths, right, everywhere, and we see that the minimum is 3 and the maximum is 70, right? So probably it's a good idea to start with a 0, 1, 2, 3, 4, 5, 6, and 7 as our stem, right? And the leaves would be all the other values, right? I mean the last value. So remember that if we have a number, let's say 147, the last digit go to a leaf and the first 2 digits go to the stem. If we have a number 35, for example, the last digit go to the leaf, the first digit go to the stem. So always the last digit go to the leaf. Everything else before that goes to the stem. Okay, so in this case, we have here we start with 3, right? So it's essentially it's 0, 3, right? Since we're working mostly here with 2 values, so that's going to be a 0, 3. So we put 3 here. Then the next value is 49. 9 goes to the leaf. 4 goes to the stem. So that value goes to this row, right? 9. Now 32. 2 goes to the leaf. 3 goes to the stem. So we put it here. 33, same thing. And then 39 goes also to the same row, but just we put 9 here instead. Now 22 goes to the third column, a row, right, where we have 20s, right? And we put a 2 in the leaf. Next one is 42. We go here, 42. Now 9 and 9. Okay, so if we have ones, that's the same thing as 0, 9, 0, 9, right? So we would put those in the first row since those are just ones. Then we have 39, which goes here. 52, so 5 goes to the stem, 2 goes to the leaf. 58, 5 goes to the stem, 8 goes to the leaf, and the last one is 70. 7 goes to the stem, 0 goes to the leaf. Okay, so now let me erase that. Okay, now one thing that we need to do, remember, we need to put all the values in ascending order, right? So let me duplicate the values for the stem, and we will just reorganize the leaves. So the first row is fine. We already have 399, that's already sorted. Then we have 2, that's sorted. For 3, we have 2, 399, that's also sorted already. Right here, it's not sorted, right? So we have 49 and then we have 42. So 2 is smaller than 9, so we just need to switch them their order, right? We have 2 and 9 here. And then the rest is, again, it's in order, so everything is fine. It is okay if we have nothing here, okay? We don't put zeros here because we don't have the value of 10 or 60, right? These are just empty and keep them empty, but don't forget to put them in your stem and leaf plot, okay? Don't just skip them. And that is it for this question. Now, the last question for this sample is construct an ogive, right? So we have 30 lawyers. Oh, and sorry, the heights of 30 lawyers. We want to construct the frequency ogive using 5 classes, right? Okay, so now again, to find the class width, we need to find what is our max. And we want to find our min. And the number of classes that we want is going to be 5. So minimum value is 67, right? And maximum value is 74. So I think it's, yeah, 67 is the smallest and 74 is the biggest value. So now to calculate the class width, we have 74 minus 67 divided by number of classes. We have 5 classes. So we get 1.4, and you can leave it as this, but I would probably just round it to 1.5 because I think that it is more convenient this way. But actually first let's check if 1.4 works. All right, if we don't round it, what happens, right? So we start with the 74, and the next lower limit would be 74 plus 1.4, which is, sorry, not 74, that's the maximum. We start with 67, so 67 plus 1.4, that's going to be 68.4. Next one will be 68.4 plus 1.4 is 69.8. Again, plus 1.4, that's going to be 71.2. And the last next one would be 71.2 plus 1.4, that's 72.6. Now 72.6 plus 1.4 is going to be 74 right? So we need 1, 2, 3, 4, 5 classes, and the 6 classes for now it's like a placeholder, 74, right? So you need to check first first and last class and see if minimum data, a minimum value goes to your first class and maximum value goes to your last class. If everything works fine, then we can continue on with the setup. If something is not assigned to the correct or to any class, then we probably need to make some adjustments. So we have 68.4. So the upper limit for the previous class would be 1 unit less, right? So we have 68.4 minus 0.1. It's going to be 68.3. And for the last one, we will just calculate the last one just to check. So we have 74 as our, for now, placeholder, right? So 1 less, 74 minus 0.1. That's going to be 73.9, right? So this is the last class that we will have. So we will not have the 74 anymore. And now let's look if we can assign minimum and maximum value to the classes. So 76, oops, 76, it is between 76 and, oh, sorry, 67. I'm sorry, 67. It is between 67 and 68.3. So the minimum value goes into the first class, so it's fine. Now 74, it is greater than 73.9, right? It will not go into the last class. So that means that the class width is a bit small, right? We need to adjust it a little bit because our last value doesn't go into any of the classes. It's too big for the fifth class, right? So that means that it is a good idea to round our class width a bit higher. So we would have 1.5 as our class width for this case, right? And don't be afraid to, adjust it a bit as long as it's somewhere within the acceptable kind of class width. If all of the values are assigned to the classes, that's fine, right? So this one will not work. Now let's start with the one that I think might work, right? So we start with 67. And now instead of adding 1.4, we will add 1.5. So because we choose this to be our class width. 1.5 to be class width, okay? So we would have 67, first class, second class, third class, fourth class, fifth class, and maybe sixth class just for a placeholder to calculate the upper limit for the last class. Okay, so we have 67 plus 1.5, that's going to be 68.5. Now 68.5 plus 1.5, that's 70 or 70.0. 70 plus 1.5 is 71.5. Now plus another 1.5, that's going to be 73. And then next one, as a placeholder, we would have 74.5, right? 73 plus 1.5, that's 74.5. Now let's check again the upper limit, upper limit of the first class and the last class and see if maximum and minimum values go into those classes. If everything is fine, then we can continue calculating the rest of the upper values, right? So we have 68.5 minus 0.1, that's going to be 68.4. And here we would have 74.5 minus 0.1, it's going to be 74.4, right? So we can now erase the placeholder and check if the minimum goes to the first class and the maximum goes to the last class. So 67 is between 67 and 68.5, so we're good. The minimum goes to the first class. And now 74 is between 73 and 74.4, so we are good again. The last value or the greatest value in our data set goes to the last class. So we're good. So now we can continue calculating the upper limits for the rest of the classes, right? So for the next one, we need to look at 70 and just do 1 digit less than that, or 0.1 units, right? So we have 69.9. And then for this one, we need to look at the lower limit of the next class. So it's 71.5. 1 digit smaller, it's gonna be 71.4. And for this one, we need to look at 73, right? So 73 minus 0.1, that's going to be 72.9. And we finished with the class intervals, right? So let me bring that down. Classes. Okay. Now, we want to calculate or to construct the ogive, right? For ogive, remember, this is the cumulative frequency, right? So we want to calculate the cumulative frequency of our data set. So before we do the cumulative frequency, it's a good idea to start with frequency and then just add them all together, right? So for the frequency, we have the first class, we will have 5 units or five lawyers have the height between 67 and 68.4 inches. Then for the second class, we have 6 lawyers that have the height between 68.5 and 69.9. Now between 70 and 71.4, we have, let's calculate, well, let's see what we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So we have 13 people, and the rest would be 2 and 4, okay? Now from here, we can calculate cumulative frequency. So remember, we just add the previous classes to the current class. So since we start with the first class, we have no previous classes before. So this is where we start. So we have 5. Now for the second row, we would have the current class with the previous, together with the previous class. So we have 5 plus 6, which is 11. Now for the third class, we have the current one plus all the previous ones. So it's going to be 5 plus 6 plus 13, which is 24. Then the next one is 5 plus 6 plus 13 plus 2, which is 26. And the last one is 5 plus 6 plus 13 plus 2 plus 4, which is 30, right? So these are the values that we have for our cumulative frequency. Let me erase the calculation and just fill in the values. So we have 11, 24, 26, and 30, right? So now we are essentially done with the table. Now we need to just construct the ogive. Again, remember that the x-axis will show us the classes, right? And for ogive, we need to we need to mark or label the upper limits, right? So here we will have classes. This is ogive. Okay, so as you can see, we don't start from 0, right? So that's why we will put here like a squiggly line first, right? Like this. That would mean that we're not starting from 0, right? And then we can continue on. So we have some kind of like information that we are skipping. So now the first one we will, that we will mark here would be 68.4. Then 69.9. Next one is 71.4. Next one is 72.9. And the last one is 74.4, right? Now remember, we need to start at 0 somewhere, and since 68.4, that's the upper limit of the first class, and we already have some frequency there, so we will start with the 5, not from 0. So in order to start from 0, we need to calculate what is the upper limit of the like zeroth class, right? So that's going to be one unit less, or 0.1 unit less than 67. So we will mark here the 0 as 66.9, right? And the y-axis, that would be our cumulative frequency, which is, again, we can start from, so it's 0, we have 5, 10, 15, 20, 25, 30, right? So as you can see, 30 is the last value, it's the biggest value. That's why we want our cumulative frequency to be tall enough to include all of these values. And now we just start marking the values on the x and y axis, right? So first one we have, again, as we said, it's going to be 0, 0, right? That's no, not 0, 0, 66.90. That's where we start. And then for the first class, we have the cumulative frequency of 5. So that's going to be a point here. Next one is for the second class, it's 11. So it would be right here, right? And then for the third class, it's going to be 24. So it's going to be somewhere around here, right? And we mark it at the upper limit of the third class and around 34, sorry, 24 on the y-axis. Now the next one for the fourth class, we have 72.9, 26, right? So it's going to be 72.9, and 26 would be somewhere here. So we would mark a point somewhere here. Right? And the last one is 74.4, right? 74.4 and 30, right? So that's going to be this one. So it's going to be an intersection right here. And now we can just connect these points with a solid line or with line segments. And this is it. This is your ogive. So that would be the end for this problem. Okay. Now next, let's go to the to this sample exam, right? We have several questions here as well. This one is mostly done by the calculator, but you can definitely do that by hand. That's totally fine with me. So first question is the heights of 10 male students in the college biology class are listed below. We have 71, 67, 67, 72, and so on, right? So we want to find mean, median, and mode. So first, if we want to use a calculator, you would input all the values into the calculator, right? Values into calculator, and then you go to stat, calc, one var stats, and then choose the list. By default, it's L1, and then click on calculate or press on calculate. And X bar, that's the first line, that would be your mean. If you want to calculate it manually, what you would need to do, again, we have a sum of all the x's, right? Or all the values divided by the number of those values. So we have 71 plus 67 plus 67 again, plus all of the values in between, plus 72 plus, oops, plus 72, right? And we divide all these values. So we need to add all of these values together, and then we divide by number of values, which is in this case, how many have? 3, 6, 9, 10, right? We divide it by 10 and we get 71, or the calculator will also give you the value of the 71. Now to calculate the median, again, you would do the same thing, but then you will need to scroll down from the mean, and closer to the end, you will see the line that says MED for median, or it is also Q2, right? And to do it by hand, what we need to do is we first need to put all the data in sorted in order. So we would have, let me have the reference. So we have 67, 67, 68, 71, 72, 72, 72, 72 again, then 73 and 76. Okay, so now it's all sorted. And now we start kind of from the sides moving towards the middle. So we can start crossing each number from the sides. So one here, on the left, on the right. And here we have two values that are in the middle. So the mean of these two values would be our median. Since we have both numbers are 72, then the median is also 72, because 72 plus 72 divided by 2, that's going to be, again, 72. So the median in this case is 72, okay? Or if we use the a formula for the position of the median, we would have it is at n plus 1 over 2, right? So that's going to be, oh wait, so we have here even number, right? So it's between, it is between n over 2 and n over 2 plus 1, which is, we have here 10 over 2 and 10 over 2 plus 1, which is 5 and 6, right? So it's between values 5 and 6. So 1, 2, 3, 4, 5, and 6, exactly here, right? So if we didn't want to calculate it this way, we could find the location by calculating the exact position. So it's between the fifth and the sixth data values, right? Okay. Mode. Remember that mode is the most frequent value in the data set. So since our data is already sorted here, let's just look at what value is the most frequent one. So we have 267, we have 472, right? So this would be our mode because this is the most frequent value. 72 would be our mode. Okay. Next question is, at a tennis tournament, a statistician keeps track of every serve. The statistician reported that the mean serve speed of a particular player was 95 miles per hour, and the standard deviation of the serve speeds was 10 miles per hour. Assume that the statistician also gave us the information that the distribution of the serve speed was bell-shaped. So we have the normal distribution, right? What proportion of the player's serves are expected to be between 105 and 125 miles per hour? So first thing that we want to draw probably, or to remember, is that we have this empirical rule, right? So we remember that we have a mean in the middle and we move 1 unit, or in this case, how many units? Standard deviation, so 10 units, right? We have mean minus one, sorry, minus one standard deviation away and mean plus one standard deviation away. So that's going to be our 68% of the whole data, right? Then once we move the same 10 units to the left and to the right, we have a mean minus two standard deviations away and mean plus two standard deviations away. That's gonna cover all of these values, right? That's gonna cover 95% of all the data. And if we again move one more step, or 10 miles per hour to the left, so x plus 3 standard deviation, and to the right, or the other way around, sorry, then this will cover all of that, right? 3 standard deviations away. That would be, let me write that at the bottom. That would be 99.7% of the whole data, right? So now if we were to put the numbers, or the data that were given, so we have 105, 125, right? And we also know that the mean is 95. So 95 would be right here in the middle. So let me just copy this bell shape. Let me actually move it down here. And let me remove these markings. We will put the actual values instead of this markings. So we have here mean is 95. So we would have 95 right here. And we have 105 and 125. So these values are going to be somewhere in this, on at this side, right? Because they are greater than 95. So now let's calculate what would be these values and these values. So we know that the standard deviation is 10 miles per hour, right? So let me move that probably here. That would be better, so that we can see the problem and the solution. So that means that if we move one standard deviation away from the mean, we would add and we would subtract 10 from 95, right? So that's going to be 95 plus 10, that's going to be 105. And 95 minus 10, that's going to be 85. So one standard deviation away from the mean, that's 85, and 105 miles per hour. Now, next one would be again, add another another 10 and subtract another 10 from the previous one, right? So we would have, here we have 105 and here we have 85. So add another 10 and subtract another 10, we get here 125. So that goes here 125, and here minus 10, that's 75, right? So with this we'll have 75. And for the last values, we have 135, right? So add another 10, and from the left side we just subtract another 10, so it's 65, right? Now let's take a look at what values we are interested in, right? So we are interested of what proportion of the player's serves are expected to be between 105 and 125. So we are interested in these values, right? 105 and 125. Okay? So as we said, this portion, right? This is our 95%. And this portion, this is 68%, correct? Now, what we want is we want only this side, only this portion. We don't even need this portion. So we are interested only in this portion. So we want to know what is the percentage of this blue area with the laser, the one that is with the laser. Okay, so how to find that? First, we want to subtract. So if we treat this 95% as our whole, right? We want to subtract this middle part, right? So essentially what we want is we want to find just like this and this portion for now, right? Because that's what we can find since it's all symmetrical, right? So from the whole 95%, we just subtract this 68%, right? So let's do that. 95% minus 68%, right? Oh my goodness, this is not correct. This is 115 here, and this is 125. Okay, let me redo that. Okay. Right. So, okay. So the marking is all only incorrect, right? So again, once again, so since we know that this, so we want to know what is the percentage right here, not just one piece, right? But these two pieces right here. Let me mark that. So we want these two essentially, okay? From 105 to 125. Now, again, we know that this portion is 68%. Now for this 3 standard deviations away, right? Not 2 standard deviations away. This is gonna be what? By the empirical rule, the whole thing. So that's the same thing as that one, right? All of that. And that corresponds to the 99.7%, right? So let me mark that here. So this is our 99.7%, okay? So now we want, first we can find what is the portion that is in these two tails, right? How can we find that? From the whole um, bell shape from 99.7%, we can subtract this middle portion, right? We can just extract it because we know that this is 68%, right? So we will be left with only this portion and this portion on the left side. So we would have 99.7% minus 68%, right? So in this case, we are just extracting this middle portion and we will just end up having, let me make it a bit smaller, only this tail and this tail, or sides. It's not, these are not tails yet, right? So this side, if we just subtract 68% of the data, like this data, right? But again, look at this. We have two of these sides, right? Two of these portions. We only need one, the one that is shaded in green. So what do we need to do in this case? These are symmetrical. These parts are symmetrical. So that means that we can just divide by 2 because we have two of them, right? If we divide the whole thing by 2, we will calculate only one side. It's either this one or this one. It doesn't really matter because they will be the same, right? So we can divide by 2 and we get 15.85%. Okay, so the answer to the question is that 15.85% of the players' serves are expected to be between 105 and 125 miles per hour. Okay, So this is the solution for this problem. Now, next problem is healthcare issues. Okay, healthcare issues are receiving much attention in both academic and political arenas. A sociologist recently conducted a survey of citizens over 60 years of age whose net worth is too high to qualify for government health care, but who have no private health insurance. The ages of 25 insured senior citizens were the following. So this is all the data that we have, right? And we want to find the P25 or 25th percentile. Now, remember that to find the some percentile, right? So we have, let's say, kth percentile. We want that k divided by 100 and multiply by total number of values plus 1, right? So this is where we would find the data, right? The location of our data. So this is the location. Okay. But before that, we need to put all the values in order. Okay, so let's first calculate the percentile, and then we will put the data in order so that, you know, there's a lot of data. We will just go, we'll just do how many we need and calculate from there. So we have P25. That's gonna be 25 over 100 times, and how many do we have? Values? We have 25 values, right? 25 plus 1, which is 26. So we have 6.5 as the answer. All right, so the position of our 25th percentile is between 6th and 7th value, right? It's somewhere in the middle. So we first find what that value is. So let's put the values in order now. So the first one would be 61. So we will probably need until 6 and 7, and the rest we don't really need then. Okay, so we have then 61, then 62. That is, I saw it somewhere here. 62, then 63, then we have 64, and then we have 65, 66, 68, two times, 69, this one. Okay, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's good enough. So we know that the position of our 25th percentile is between 6 and 7, right? So we have 1, 2, 3, 4, 5, 6, and 7. So it's going to be between these two values. So now in this case, you can either interpolate or just find the mean of these, right? And we have 65 plus 66 divided by 2, we would have 65.5. And that would be your 25th percentile. Another thing that you might use is that remember that Q1 corresponds to the 25th percentile. So what you can do is you can just unsorted put all your raw data into the calculator, into list one, and then click on the one var stats where it will show you the 5-number summary that you can use Q1 to say what is your P25, right? Or your 25th percentile, because that would be exactly the same. And it's easy. This number is just easier to calculate since it corresponds to the quartile one. You cannot use the same technique if I ask you something like, what is the 40th percentile, something like that, okay? You will need to do that manually in this case. Okay. Next question is, well, many firms use the on-the-job training to teach their employees new software. Suppose you work in a personnel department for a firm that just finished training a group of its employees in new software, and you have been requested to review the performance of one of the trainees on the final test that was given to all trainees. The mean and standard deviation of the test scores are 72 and 2 respectively, and the distribution of scores is mound-shaped or symmetric, right? Or it's like bell shape and symmetric. Suppose the trainee in question received a score of 71. Compute the trainee's z-score. Okay, so what we need to calculate is z-score. Remember that the formula for z-score is x minus x bar over s, or if we're looking at the population, that's going to be x minus mu divided by sigma, right? This is the same thing. This one is for sample, this one is for population. Right, so we are given that the mean x bar is 72 and the standard deviation S is 2, right? We also know that X, or the value that the trainee received, the score, is 71. So we can use these values and plug them into the formula and get the z-score, right? So z-score in this case would be 71 minus 72 divided by 2, which is negative 0.5. Okay. And that is it. This is all you say. Now, is this value normal or, I mean, usual or unusual? This value is usual because it is within the negative 2 and 2 interval, right? So everything outside of that is considered unusual. Everything within that region or interval is considered usual. So we are working with the usual value, right? Okay, next question. The selling prices of mutual funds change daily. In order to study these changes, a sample of mutual funds was examined and the daily changes in price are listed below. So here are the prices. Determine the lower and upper fences. Are there any outliers according to this criterion? Okay. So first thing what we need to do is we need to put all the values in order, right? So that we can if we want to find the five number summary in by hand, we will need to put all the values in order. If you want to use a calculator, that also works perfectly. You can just plug in all the values as they are, right, in the calculator, and you can get all the information. Mean value, Q1, median, Q3, and maximum, right? So for the lower and upper fences, we need only Q1 and Q3, right? So these values are corresponding to 25th percentile and 75th percentile, right? So we can do manually as well. So if we decide to do this on the calculator, again, you will just plug in all the values into calculator and it will give you the all the solutions. If you want to do it manually, then you need to put all the values in order. So let me put them in order for you so that we can try to do it manually. So first one is negative 0.07, negative 0.03, negative 0.01. 3 times 0, then we have 0 0.02, 0.03, 0.05, 0.07. Oh, and more. Let me probably move these a bit closer to each other so that I have a bit more space. We have 0.10, 0.18, and the last one is 0.29. Yeah. Okay. Right. So if we want to do it manually, again, we start removing all the values from the edges, right? Until we reach the middle. So this is our Q2, right? Or median. So this is needed for separating the data into the left side and right side, right? So we see that 1, 2, 3, 4, 5, 6 values on the left side and 1, 2, 3, 4, 5, 6 on the right side. But now, where do we put this 0.02? You will need to put it in both of them, right? So you will have 7 values in the left half, and you would have 7 values in the right half. So we would have then, let me erase those zeros. So if I am to treat the first half to calculate the Q1, I will be looking at the values from negative 0.07 to 0.02. Okay, again, the same technique. Each value, one by one, we start erasing them. So this is the location. I mean, this is where we have our Q1, right? Okay. So we found quartile 1. Now we do the same thing, but with the right side. Let me erase those. And now we are looking at these values, right? Again, the same thing. So this is the middle, right? So this is my Q3. I start just erasing all the values from or crossing all the values from the sides until I reach the middle, right? So I have my Q1 equals to 0.00 and Q3 equals to 0.07. Yes? Now, or you can calculate it the same way using this formula. We would have 25 divided by 100 times n plus 1. So we have 0.25 times, how many values we have total? 3, 6, 10, 13, right? So we would have 0.25 times 13. That's going to be 3.25, right? So it's going to be 1, 2, 3. It's between 3 and 4, right? So we either interpolate or we just find the middle. And in this case, it is going to be negative 0.01 plus 0.00 over 2. So that's going to be negative 0.005, which we will just round to, what, 3 decimal places in this case? No, 2 decimal places. Yeah, okay. So we would have just either 0.00, or if we calculate it using this formula, that's going to be 0.01, which is close enough, okay? So you can use that value as well. As I said, you can just do the mean between them, but more correct would be to do the interpolation. Okay, so let me just use these values, right? So to find the upper and lower fence, we need to use the formula, right? Q1 minus 1.5 Q3 minus Q1. And upper fence, we would have Q3 plus 1.5 Q3 minus Q1. And we have here Q1 is 0 minus 1.5 times 0 0.07 minus 0. We would have, let me move that a bit. We would have negative 0.105, or we can round it to negative 0.11. And the upper fence would be 0.07 plus 1.5, 0.07 minus 0, that's going to be 0.175, or we can round it to 0.118. Okay? Now let's look at the data. Do we have any outliers? Do we have any values that are, sorry, yes, 8. That's correct. So do we have any values that are greater or smaller, that are greater than 0.18 or smaller than negative 0.11? So our smallest value is 0.07. It is within the region, within the fences, right? So if we were to draw those fences, right, we have negative 0.11 and 0.18. So the minimum value that we have is negative 0.07, which is inside of the fence. But the greatest values that we have is these two, right? So 0.18 is on the border, so we can include that into the normal data, and 0.29 is outside. It's going to be somewhere here, right? 0.29. So this value is going to be an outlier in this case. Or if we remember, the fence was, if we don't round it, it was 0.175. If you decide to keep it this way, then 0.18 would also, wait, no, not this one. This one, 0.18 would also be an outlier. So if you round it, then it's not an outlier. We have only one outlier. If you use it as it was, like that, so our fence would be 0.175. And we have 0.18 outside here of this value, right? So we have two outliers, 0.18 and 0.29. So these are two outliers, okay? All right, next question is number 6. The following is the sample of 19 November utility bills from the neighborhood. So we have all the data, and I see that it's all sorted already. So the question is, we want to find the 5-number summary. The easiest way would be just to put all the data into the calculator and go to the one var stats. This case, you can find your minimum, Q1, median, Q3, and maximum. So this is your 5-number summary. Or you can, again, you can calculate it the way that we did the previous time, just by crossing out all the values starting from the edges. Or you can also calculate it knowing that quartile 1 is P25, right? It's 25th percentile. Median is 50th percentile. Quartile 3 is 75th percentile. So you can calculate minimum. You can calculate those values also using the formula for the percentiles. So whichever you prefer. I don't mind any of those. So you can just, calculate using the TI-84 and get the answers, or we can just calculate it the old-fashioned way, kind of just marking or crossing all the values until we reach the middle, right? So this is our Q2, right? Or median, 76. And now again, we keep the 76 for this portion and for this portion. So for this portion, again, what do we have? Start crossing those. We have two values, so that's the middle of these two values. We have 72 plus 74 over 2. That's going to be 73. So Q1 in this case would be 73, right? And again, the same thing goes for the second portion. We have, again, 70 or 84 and 84, right? As you can see, both values are the same, so the Q3 would be in between them, which is again also 84, right? So the difference, the mean of these two values would be the same value. So, and again, minimum, that's just the smallest value, and maximum, that's the greatest value. So in this case, our minimum is 52, our Q1 is 73, our median is 76, our quartile 3 is 84, and maximum value is 96. So this is our 5-number summary. Now the last question is, I think it's the last, or how many? Oh, two more questions, right? No, that's the last question. Okay, so the last question we have here is the cholesterol levels of 30 adults are listed below. Draw a box plot that represents the data. Okay, so the same idea. We need to first find 5-number summary. So for now, you can use again the whatever technique you want. If you want to use a calculator, that's totally fine. So I will just fetch the numbers from the calculator. So I have minimum 154. Quartile 1 is 176. Median is 196.5. Quartile 3 is 213, and the maximum is 275. Okay. Now, before I start graphing the box plot, I need to calculate or find if I have any outliers. For that, I need to calculate lower fence and upper fence, right? So lower fence would be Q1 minus 1.5, Q3 minus Q1, which is 176 minus 1.5, 213 minus 176, which gives me a value of 120.5. And the upper fence is Q3 plus 1.5, Q3 minus Q1, which is 213 plus 1.5, 213 minus 176, which will give me a value of 268.5. Okay, so now I am ready to graph it, right? So I look at the lowest value and highest value. So this is the lowest value, this is the highest value that I have. So I need to start at somewhere 150 and probably finish at maybe 300 or something like that. I can also start with yeah, with 100 if I want to, right? But I think 150 would be good enough. So I have 150 here, then 200, 250, 300, and I think that will include everything. Okay, now let's start with the quartile 1 and quartile 3. We will just draw the box plot and locate the median. So quartile 1 is 176. It's gonna be somewhere here in the middle, right? So this is where I put the lower side of my box. So Q1. Q3 would be 213. So if this one is about 225, so 213 would be somewhere here probably, right? So I will put a marking here. So that's my Q3. Again, that would be a good idea if you mark your values. All right. And now I can draw a box. Now, median would be inside of the box, okay? 196.5. So it's really close to 200, right? So it's going to be 196.5 somewhere here, right? Or even closer to 200. Now, with the whiskers, let's first locate the lower fence and upper fence, right? So somewhere separately if you want. So lower fence is 120.5 and upper fence is 268.5. Now let's look at the raw data that we have. Do we have any value that is smaller than 120.5? No, the smallest that we have in our data set is 154. So that goes inside, right? It's going to be somewhere inside of this interval. But what about 275? So 275, that's somewhere outside, right? 275 is greater than 268.5. Okay, so this is an outlier. Let me mark that as an outlier. What about 255? 255 is still inside of the normal range, right? So 255. So that means that we have only one outlier. So what it means is that our whisker, right whisker, will go to 255 because now it's our new maximum, right? So we would draw from the from the right side of the box until we reach 255. So it's somewhere here. Okay. That's our whisker. And the left side would be from the left side of the box until the minimum, right? 154. So that's going to be somewhere here. Okay. 154. Okay. And yeah, and the only thing that's left to do is to mark our outlier. It's 275, so it's somewhere here. We mark it as a star, and this is how our box plot will or should look like. Okay. And that is, oh no, I have one more question, right? Okay. A survey of 200 public universities indicated that 25th percentile of a yearly tuition cost of the universities was 4,400. 75th percentile was 7,900. The minimum value was 2,000, median was 6,000, and maximum was 10,000. Use this information to construct a box plot for the yearly institution cost. So in this case, we're just given the information. We don't need to calculate anything. We just need to plot it, right? So what information do we have? We have the 25th percentile, which corresponds to quartile 1, right? That is 4,400. We are given the 75th percentile, which is quartile 3. 7,900. We are given the minimum, which is 2,000. We're given the median, which is 6,000. And we're given the maximum, which is 10,000. So what they want us is to use this information to draw a box plot. Again, the number line, we start with so 2,000 is the minimum, 10,000 is the maximum. So I think it's not a bad idea to just start from 0 and then have like every 2,000s, right? So we have 4,000s here. 6,000 here, 8,000 here, and 10,000 here, and maybe 12 just so that we have a full number line. Okay, and now we start just marking the values. So minimum is at 2,000. So this is where we have our whisker. We start our whisker. Then the Q1 is 4,400. So it's gonna be somewhere here. So this is where the box will start. Q3, that's 7,900. So that is gonna be actually no, so 5,000 is here, so 440 would be somewhere here. 4,400. Okay, this is 2,000. Now Q3, quartile 3 is 7,900, so it's approximately closer to the 7,000, right? No, to the 8,000 to here. So it's gonna be like 100 less than that. So this is where we will mark our box, right? Then the middle or the median is 6,000. So this is a line right here. And the maximum is 10,000, which is a line right here. So we need to connect the minimum with the box and the maximum with the box. Oops. So that we have the whiskers. And that is it. And the median is 6,000. Okay. So this is how you draw the box plot for this type of questions. And that is it. These are all the questions. Hopefully you can follow along. And that is it. Thank you for your attention.